changes around us. Have you ever wondered why water freezes into ice or turns into steam? Or how sugar mixes perfectly into a cup of tea? The world around us is full of interesting changes, and it is all because of the different states of matter. In this chapter, you will learn how matter changes its state between solid, liquid, and gas. Solids, liquids, and gases. We are surrounded by different kinds of things like air, trees, soil, water, books, clothes, etc. These are all matter. Matter is anything that has mass and occupies space. It is made up of very small particles called molecules that cannot be seen with the naked eyes. Matter can exist in 3 different states: solids, liquids, and gases. Do you know? 1 drop of water contains billions of water molecules. Solids. Properties of solids are as follows. Solids have fixed shapes. Solids have fixed volume. Particles are closely packed together. Solids are rigid in nature. Solids are incompressible. For example, a book, a pen, a laptop, etc. Liquids. Properties of liquids are as follows. Liquids have no fixed shapes. Liquids have fixed volume. Particles are close together, but they can move freely. Liquids can flow and take the shape of the container in which it is kept. For example, water, juice, milk, etc. Gases. Properties of gases are as follows. Gases have no fixed shape. Gases do not have fixed volume. Particles are far apart from each other and move very easily in all directions. They take up all the space available in the vessel in which they are kept. For example, gases like carbon dioxide, oxygen, nitrogen, etc. Liquids and gases can flow easily, so they are called fluids. Hence, these 3 states of matter are different from each other based on the arrangement of molecules, the space between them, and the way these particles move. Let us take a quick look to understand the properties of solids, liquids, and gases. Changes in the states of matter. Matter can change its states by heating or cooling. For example, when we heat ice, solid, it changes into water, liquid. When we heat water, liquid, it changes into water vapor, gas. On cooling, water changes back to ice and water vapor turns back into water. The different processes that cause change in state of matter are as follows. Melting, solid to liquid. When a solid is heated, its particles begin to move rapidly. When enough heat is added, the solid melts and turns into a liquid. This change is called melting. For example, melting of ice cream, candle, ice, butter, etc. Freezing, liquid to solid. When a liquid is cooled, the movement of its particles slows down and come closer to each other. If the temperature is low enough, the liquid will freeze and turn into a solid. This change is called freezing. For example, freezing of water, snowfall, etc. Evaporation, liquid to gas. When a liquid is heated, its particles gain energy and move faster. If the temperature is high enough, the liquid will evaporate and turn into a gas. This change is called evaporation. For example, drying of clothes, boiling of water, formation of salt, etc. Condensation, gas to liquid. When a gas is cooled, its particles lose energy and slow down. When the temperature drops enough, the gas molecules condense and turn into a liquid. This change is called condensation. For example, foggy mirrors and windows, morning dew, fog, water droplets on a glass of cold water, etc. Do you know? LPG, liquefied petroleum gas, is a gas used in our homes for cooking. It is stored in cylinders as a liquid under high pressure, which allows us to use it safely. Solutions. A solution is a mixture of 2 or more substances. For example, when we dissolve a spoon of salt in water, it gets dissolved in it completely and a clear solution is formed. Here, salt is the solute and water is the solvent. Some other examples of solutions are sugar in water, juice, etc. Types of solutions. There are different types of solutions based on the states of solute and solvent present in the solution. Let us study about them in detail. Solid in liquid. In this type of solution, the solid is added as a solute and a liquid is the solvent. The solution formed can be either soluble or insoluble. For example, salt, sugar, chalk and sand solutions. Gas in liquid. This type of solution contains a gas as solute dissolved in a liquid that is the solvent. Some gases like oxygen dissolves in water. For example, in a fizzy drink like soda, carbon dioxide gas is dissolved in the liquid. When we open a soda bottle or a can, we hear a fizz sound because the gas escapes from the liquid. Liquid in liquid. In this type of solution, the solvent and solute both are liquids. The solution formed can be miscible, honey in water, or immiscible, liquids, oil in water. Gas in gas. In this type of solution, both the solvent and solute are gases. For example, air is a mixture of gases like oxygen, nitrogen, carbon dioxide, etc. Saturated and unsaturated solutions. Solutions can also be classified in two types based on the amount of solute dissolved in the solvent. These are as follows. Saturated solution. A solution in which no more solute can be dissolved in it at a given temperature. If you add more solute, it will not dissolve and will settle at the bottom of the container. Unsaturated solution. A solution in which more solute can be dissolved in the solvent at a fixed temperature. For example, if you add sugar to water and it dissolves completely, then it is an unsaturated solution. However, if you keep on adding sugar and it does not dissolve anymore, then it becomes a saturated solution. Miscible and immiscible liquids. Solutions can be classified into two types based on their ability to mix with each other. These are as follows. Miscible liquids. Liquids that mix completely to form a solution like water and ink, water and milk, or water and honey. Immiscible liquids. These are the liquids that do not mix with each other and form separate layers like oil and water, petrol and water, milk and butter, etc. However, two immiscible liquids can be mixed together with the help of an emulsifier. This type of mixture is called an emulsion. A common example of an emulsion is mayonnaise, where water and oil are mixed using egg yolk as an emulsifier. Types of changes. In our life, we see many changes happening around us. The change is said to be occurred when the shape, size, color, or composition of any substance changes. These changes can be fast or slow, reversible or irreversible, desirable or undesirable, and physical or chemical changes. Physical change. A physical change is a change in which the form or the appearance of a substance changes, but the substance itself does not become a new substance. In a physical change, the chemical composition of the substance remains the same. Characteristics of physical change. No new substance is formed. The chemical composition of the substance remains the same even after the change. Only the physical properties such as shape, size, color, or state may change. Physical changes are usually temporary because they can be reversed. Examples: melting of butter. Butter changes its state from solid to liquid, but its chemical composition remains the same. Melting of ice. Water changes its state from solid to liquid, but can be reversed back by cooling. Tearing of paper. Paper changes its shape and size, but it still remains paper, that is, its chemical composition remains the same. Stretching a rubber band. The shape and size of the rubber band changes temporarily without changing its chemical composition. Breaking of glass. The glass breaks into pieces, but its material remains the same. Expansion and contraction. When a material is heated, its particles move faster, causing the material to increase in size. This increase in size due to heat is called expansion. For example, heating the lid of a jar helps to open it because the lid expands. Similarly, a balloon placed on a bottle with Warm water expands as the air inside warms. When a material is cooled, its particles move slower, causing the material to decrease in size. This decrease in size due to cooling is called contraction. For example, a balloon on a bottle of cold water shrinks and water contracts when it freezes into ice. When a copper wire is heated, it expands and becomes longer. When it cools, it contracts and becomes shorter. This is a physical change, and the copper does not change chemically. Do you know? Thermometers used to measure the temperature work on the principle of expansion and contraction. The liquid, usually mercury, inside expands, moves up when heated, and contracts, moves down when cooled. Chemical change. A chemical change is a change in which the substance changes into a completely new substance with different properties. In this type of change, the original substance undergoes a chemical reaction and is usually not reversible. Characteristics of chemical change. A completely new substance with changed chemical composition is formed. Chemical changes are permanent as they are irreversible. Chemical changes involve energy changes like absorption or releasing of heat. Examples: burning of paper. Paper turns into ash and gas and a new substance is formed, so it is a chemical change. Rusting of iron. It is a chemical change as iron reacts with oxygen and water present in the atmosphere to form rust, an irreversible process. Digestion. The body breaks down food into simpler and absorbable form using enzymes and chemicals. Making curd from milk. Bacteria converts milk into curd by changing its chemical composition. Cooking. Heat changes the food into new substance with different chemical compositions, and this change is irreversible. Key words. Matter. Everything around us that has mass and occupies space. Solution. A mixture of two or more substances where one substance, solute, dissolves in other substance, solvent. Saturated solution. A solution in which no more solute can dissolve in the solvent. Unsaturated solution. A solution in which more solute can still be dissolved in the solvent. Miscible liquids. Liquids that mix together completely to form a solution. Immiscible liquids. Liquids that do not mix with each other and form separate layers. Physical change. A change in which the form or appearance of a substance changes, but its chemical composition remains the same. Chemical change. A change in which a substance changes into a completely new substance with different properties. Expansion. When a substance increases in size on heating. Contraction. When a substance decreases in size on cooling. Let's recall. Changes around us. Solids, liquids and gases. Changes in the states of matter. Solutions. Solute plus solvent. Types of changes. Solids, liquids, gases. Melting. Solid to liquid. Freezing. Liquid to solid. Evaporation. Liquid to gas. Condensation. Gas to liquid. Types of solution. Solid in liquid. Gas in liquid. Liquid in liquid. Gas in gas. Saturated and unsaturated solutions. Miscible and immiscible liquids. Physical change. Expansion, contraction, chemical change.